Welcome to my YouTube channel. Today we'll be discussing fraction, but we'll focus our attention on addition of fraction. As simple as this topic sounds, you will come across fraction in a whole lot of mathematical topics. So the moment you understand how to maneuver your way around it correctly, you find fraction very easy. And a quick reminder, we have basically three types of fraction. We have proper fraction, we have improper fraction, and we have mixed fraction. Improper fraction, this is a situation whereby the numerator is less than the denominator. For example, we have 2/3 that we have here. Once the number above is less than the number below, is a proper fraction. The second type of fraction is an improper fraction, where the numerator is greater than the denominator. When the number above is bigger than the number below, that's an improper fraction. Now, a mixed fraction is the third type of fraction, where we have a whole number combined with a proper fraction. A whole number combined with a proper fraction. Don't forget, we say proper fraction is when the numerator is less than the denominator. So we have a whole number here and a proper fraction. So we'll be working with this, but we'll focus our attention on addition of fraction. So let's see how we can go about that. Let's solve some questions. Awesome. We have some questions here, but they are basically addition of fractions. So let's dive straight into solving the question. So we say solution number 1. Solution 1. Let's get question number 1. Awesome. So with this, let's quickly see how we can go about this. In fraction, you have to, if you are adding fraction, it is very key. You make use of LCM, lowest common multiple. If you have not, for a quick reminder to brush yourself up, kindly check our YouTube channel, this channel on lowest common multiple LCM for junior secondary school mathematics. You can quickly brush up your brain with that. So a quick reminder. So we'll be making use of LCM for fraction. So now, if you are making use of LCM, that means you have a line underneath in which you look for the LCM. So let's get a template to make use of here. Great. So the LCM of 3 and 7, if you look for the LCM, it's 21. LCM of 3 and 7 is 21. So how many times will 3 go in 21? That's 7 times. That's 7 times this one that you have here to give you what? 7. But because we are working with addition, we are going to add. Now, how many times will 7 go in 21? That's 3 times. You now say that 3 times this 2, it will give you what? 6. Awesome. Very easy. So let's put our equality sign here. Great. So let's adjust this here. Awesome. So let's go again. The LCM of 3 and 7 is 21. How many times will 3 go in 21? 7 times. 7 times 1 is 7 plus. How many times will 7 go in 21? That's 3 times. 3 times 2, that's 6. Great. So let's make use of this as a template. So if you now say 7 plus 6 will give you what? 13. 7 plus 6 will give you 13 over, you have 21 under it. So that is your answer. You have successfully added 1 over 3 plus 2 over 7. So you have 13 over 21. So that's the answer. But don't forget, you need to look at it carefully. If there's any number that can go through both the numerator and the denominator here successfully, but if none, you leave your answer like this. So since there is no number that can go through this 13 and 21 at the same time successfully, the answer is 13 over 21. So that's for the first question. Let's quickly dive straight to the second question. So we'll say solution number 2. Solution 2. That's our question. Great. So 1 over 2 plus 2 over 5. 1 over 2 plus 2 over 5. It's in the same way. We are going to look for the LCM as well. Like I said earlier, once you are adding fraction, you need LCM. It is very important to understand that basic principle. You can always brush up with our video on LCM on this YouTube channel. It is very key. So also we'll be making use of it here as well. So let's see how we can do this again. The LCM of 2 and 5 is 10. LCM of 2 and 5 is 10. So how many times will 2 go in 10? That's 5 times. That 5 times this one will give you 5. 5 times 1 will give you 5. But because we are working with addition at the middle here, so we'll do the same thing. How many times will 5 go in 10? That's 2 times. 2 times 2 that we have here, that's 4. Awesome. So we've been able to iron out that. The next thing now for us, let's bring this down as a template. Awesome. So we will now say 5 plus 4 here will give us what? 5 plus 4 will give us 9. 5 plus 4 will give us 9. Great. So looking at this now, is there any number that can successfully divide 9 and 10 at the same time? No. So our answer will be 9 over 10. Very easy. So let's dive straight to question number 3. This one is 3 fractions. So it's still the same way. Still the same way. We are solving using the same method. So let's come here and say solution number 3. Awesome. That's for question number 3. Like I said, if you are working with fraction, you need to do what? To look for the LCM. It is very important. Look for the LCM. So let's just get this as a template for our LCM. Great. So now the LCM, you do these 3 simultaneously as well. The LCM of 7, 11 and 7 will give you what? 77. The LCM of 3 of them will give you what? 77. Now, let's adopt the same method. How many times will 7 go in 77? That's 11 times. 11 times 2 will give you 22. Because we are working with addition. How many times will 11 go in 77? That's 7 times. That's 7 times 3 here. That's 21. So also, how many times will 7, this 7 that we have here, how many times will it go in 77? That's 11 times. 11 times 6 that we have here, that's 66. 66. Great. We're almost there. Now, all we need to do now is to add all our numerator that we have up here. So add them up. Awesome. You need to add everything that you have up here. Now, how are you going to add it? Simple addition. Just do it. 22 plus 21, that's 43. 43 plus 66, that will give you 109. That will give you 109. So adding all you have here will give you 109. Awesome. So now your answer is correct this way, but it is in improper fraction. This is an improper fraction. Don't forget the way we explained earlier. Now you can leave your answer like this, you are still correct, but depending on how you want your answer to be, and you can change an improper fraction to a mixed fraction. Okay, I didn't say that earlier. Since we have a proper fraction, improper fraction, a mixed fraction, so an improper fraction can be converted. You can change it to a mixed fraction. How will you do that? All you just need to do is to ask yourself, how many times will 77 go in 109? That is, how many 77 are you going to see in 109? Just one. That's the whole number that will be there. Now, if you remove 77 from 109, the number that will be left will be 32. So how many times will 77 go in 109? Just one. Remainder 32. And you leave your 77 at the denominator here. It is very easy. By implication, if you say 77 times 1, it will give you 77 plus 32, it will give you 109. So you can leave your answer in an improper fraction or a mixed fraction. You are still very correct. So let's dive straight to question number 3. Question number 4. Question number 4. This one involves mixed fraction. So we'll come here and say solution number 4. Solution 4. Great. This one involves mixed fraction. So we have 3 over 1 over 4 plus 1 over 2 over 5. Now, when a fraction involves mixed fraction, you can do it in 2 different methods. I will quickly brush through the 2 methods. They are still the same. Anyone that suits you, you can go ahead and do that. So let's get a template. Don't forget, whenever you are adding fraction, you will need LCM. Okay, let's quickly do the first method. The first method involves dealing with the whole number first, because this is 3 whole number 1 over 4, and we have 1 whole number 2 over 5 here. Let's deal with the first method. Now the first method is add the whole number first. 3 plus 1 will give you 4. You are dealing with the whole number first. 3 plus 1 will give you 4. Now let's deal with the fraction beside them. The LCM of 4 and 5 is what? 20. The LCM of 4 here and 5 is 20. So how many times will 4 go in 20? That's 5 times. 5 times 1 that we have here will give us 5. Plus, how many times will 5 here go in 20? 4 times. 4 times 2 that we have here will give us 8. The same method that we've been using. Very easy. Very easy. So all you just need to do now is to add your numerator that you have here. Great. So you now say 5 plus 8 will give you what? 13. That's 4 whole number, 13 over 20. Is there any number that can successfully cut this 13 and 20 at the same time? No. So you leave your answer as 4 whole number, 13 over 20. Awesome. You can also, let's quickly see the second method, or let's bring down what we have here. You can also use another method which is very simple as well. Okay, let's get a template. You will discover that we will still get the same answer, 4 over 13 over 20, which is our answer. Let's just use this as a template. Now, this is what we want to do. This is the second method. You remember the first method will deal with the whole number first. Now this one, you convert this mixed fraction to an improper fraction. You convert this to an improper fraction, then you solve using the LCM method as well. So let's quickly do that. 4 times 3 will give us what? 12. 4 times 3 will give us 12. 12 plus this one here will give us 13. We now have 13 over 4. 13 over 4. Plus, because we are dealing with plus here. Great. Let's put this as a template. So 5 times 1 here will give us 5. Plus 2 will give us 7. So we now have 7 over 5. I'm sure you can always rewind to get my explanation again. So from here now, you can go through our solution as usual and get the LCM, and at the end of the day we are going to get the same answer as we've gotten in our first method. So let's quickly see. LCM of 4 and 5 will give us 20. 4 and 5 here will give us 20. How many times will 4 go in 20? That's 5 times. 5 times 13 will give us 65. Great. Because we are dealing with addition. How many times will 5 go in 20? That's 4 times. 4 times 7 will definitely give us 28. Great. We are almost there. We'll just add the numerator. So we'll now say if you add 65 and 28, it will definitely give us 93. Awesome. So we have 93 over 20. You can leave your answer like this, but for the fact that we want to prove that we'll get this same answer, this 4 number 13 over 20. So let's quickly see what we can do. Great. So how many times will 20 go in 93? How many times will 20 go in 93? That's 4 times. Because 4 times 20 will give us 80. So 93 minus 80 will give us what? 13. So we now have 4 whole number, 13 over 20. Look at what we have here. And look at what we have here. Still the same answer. So any method that suits you from this first one and the second one, you are good to go. So let's dive straight to the final question. This one involves 3 mixed fractions. Three mixed fractions. So we'll say solution number 5. Great. So either we use the first method or we use the second method, since it involves mixed fraction now. Okay, let's see what we can do very quickly. Let's just use this as a template. Let's deal with the whole number first. 2 plus 3 will give us 5. 5 plus 5 will give us 10 here. So let's deal with the proper fraction beside them. So the LCM of 3, 4, and 2 will give us 12. The LCM of 3 of them will give us what? 12. So let's go. How many times will 3 go in 12? That's 4 times. 4 times 1 here will give us what? 4. How many times will 4 go in 12? 3 times. 3 times 1 will give us what? 3. How many times will 2 go in 12? That's 6 times. 6 times 1 will give us what? 6. We now have 4 plus 3 plus 6. Awesome. We'll add those numerator. So 4 plus 3 will give us what? 7. And 7 plus 6 will give us what? 13. We have 10 number, 13 over 12. Now, we have this whole number, but a mixed fraction will always be with a proper fraction. Now, we have 13 over 12. Is 13 over 12 a proper fraction? No. It's an improper fraction because 13 is greater than 12. So we need to be very, very careful here. Now, what we need to do is to ensure this 13 over 12, we change it to a proper fraction first. This 13 over 12. So let's deal with this 13 over 12 first. This, what we have here, is not a mixed fraction because we're having a whole number with an improper fraction beside. So we work with this 13 over 12 first. The moment we were able to iron out, we change this 13 over 12 to a proper fraction first. Once we're able to do that, then we can forge ahead. Okay. Let's see. This 13 over 12 now, we need to change it to a mixed fraction. Now, how many times will 12 go in 13? Just one time, just once. So 13 minus 12 will give us what? 1. By implication, it means we have converted this 13 over 12 to a mixed fraction, which is 1 over 1 over 2. So if we say 12 times 1 will give us 12 plus 1, that's 13 over 12. Now that we now have 1 over 12, don't forget we have 10 here as whole number initially. So all we just need to do is to add our 10 and this 1 together. To add our 10 and this 1 together is very key. We understand this because we will come across some of this. Awesome. So if you now say this our 10 plus this our 1 will give us what? 11. So that's the answer. 11 whole number 1 over 12. So very easy, very easy. So if you use the second method too, converting the mixed fraction, if you are converting the mixed fraction, let's see what we quickly have. You will still get the same answer. Awesome. So let's quickly see what we can do. Let's quickly convert all these mixed fractions. So it will say 3 times 2 will give you what? 6. 6 plus 1, 7. That's 7 over 3. That's what we have here. We have 7 over 3 here. Good. Let's convert this one. 4 times 3 will give you what? 12. 4 times 3 is 12. 12 plus 1 will give you what? 13. That's 13 over 4. Great. Let's convert this. 2 times 5 is 10. 10 plus 1, 11. That's 11 over 2. 11 over 2. Awesome. So we've been able to convert these mixed fractions to improper fraction. Awesome. So we'll solve it the same way. At the end of the day, we are still going to get our answer 11 over 1 over 2. Okay, let's see what we can do using the same principle. Great. So the LCM of 3, 4, and 2 is what? Is 12. So let's pick it one after the other. How many times will 3 go in 12? That's 4 times. 4 times 7 will give you what? 28. We are dealing with addition. How many times will 4 go in 12? That's 3. 3 times 13 will give you 39. We are dealing with addition. And the last one, how many times will 2 go in 12? That's 6 times. 6 times 11 will give you what? 66. Great. So it is very key. You need to understand that you take it step by step so that you will not make mistake. So let's add what we have up here. Awesome. So let's add it one after the other. Awesome. So let's say the first one, 28 plus 39. 28 plus 39 will give you 67. 67 plus 66 will give you 133 over 12. That's very correct. So This is an improper fraction, so let's try and see how we can convert it to a mixed fraction and compare our answer with the first answer. So how many times will 12 go in 133? How many times will 12 go in 133? That is 11 times. Because if you say 11 times 12 will give 132. That means you are left with 1. So if you say 11 times 12 will give you 132, you mean that 1. So you have your final answer to be 11 whole number 1 over 12. If you check it with what you have here, 11 whole number 1 over 12. That's very correct. You can always pause, rewind this video for better clarification and understanding. Don't forget to drop a comment with us if you have any issue, and kindly help us to like this video and subscribe to this YouTube channel, My Simple Maths, and press the notification bell so that you can always receive notification from us whenever we post a new video. Thank you.